All right, hey everyone. So today we're doing 4.4, which is all about congruence and using congruence transformations to show how you would map one shape onto another shape. So first off, what does it mean to be congruent for shapes? It means that the corresponding angles are congruent and corresponding sides are also congruent. Now, what does it mean for the sides to be corresponding or the angles to be corresponding? It's the ones that go together, and the way that we tell that is if we're looking at a congruent statement, like triangle ABC is congruent to triangle DEF, it's all about the letter order. So, for example, A and B are the first two letters, D and E are the first two letters, AB will be the same length as DE in congruent triangles. So there's A, B, and DE in the picture. So then the same thing for BC, the last two letters, and EF, the last two letters. Those will be the same as each other. And then lastly, AC and DF, the first and last letters. So that's the way it works for sides. And then for angles, it's even simpler. A is the first letter, so measure of angle A will be the same as the measure of angle D, which is also the first letter in DEF. Then for B, measure of angle B will be the same as measure of angle E. So we have A and D, and then we have B and E in the picture. And then lastly, C and F, the last letters. And C and F in the picture. All right, so that's how congruence works for shapes. This is one way that you can show two shapes are congruent. Another way to show it, which we'll get back to this way a little bit more in chapter 5 when we talk about triangles a little more intensively. The way that we're going to focus on today is down here. You can also show congruence in the coordinate plane by using a combination of translations, rotations, reflections, that sort of thing, to move one shape on top of another shape. If you move it on top and it overlaps perfectly, then that tells you that the two shapes are congruent. So for this first one, you'll see questions like this, where you've got two shapes here and you have to describe the transformation that gets you from ABC to A prime, B prime, C prime. So if all the options are open now, you've got translations, rotations, reflections, you have to figure out what it is that maps it onto the other shape. So if your shapes aren't oriented the same way, that's a good red flag that it's probably either rotation or reflection. But if your shapes look pretty much the same and are oriented the same way, like these two, this is just a translation. We have to move it over and up. Now, on this one, you have to pay a little bit of extra attention here. This is 4 and this is -8. And that shows us that our graph here is scaled by 2. So this goes 0, 2, 4, -2, -4, -6, -8. So when you're counting the squares on this one, you have to give each of them 2. They don't count just for 1. So starting here to go right, we have to go right 2, 4, 6, 8. So this is a translation. And it's a translation where we go right 8. And then we have to go up 2 to get to A prime. And in order to check it, you might want to check that all of the points have to go right 8 and up 2 to get to their corresponding point. In this case, they do. And then we're all done on this one. So you have to say what kind of a transformation you're doing and how you're doing it. All right, so another kind of problem that you're going to see is going to look like example 2, where you're given a whole bunch of shapes and you have to decide which ones are congruent to each other. And not only that, but also say what type of a transformation might have to take place to get from one to the other. You don't have to be as specific in this scenario. We really are mostly interested in just which shapes are congruent, but give some kind of a reason for each one. So for example, 2 and 6, we've got this little square down here and this little square. They're the same size. And that's just a translation. I would just move 2 over and up. Another one, let's see, we have also 1 and 8. 1 and 8 would probably be more of a rotation, though, because 8 over here is not oriented the same way. You'd have to rotate it a bit to get it to land on top of 1. Or let's see, how about 5 and 1? That one would be a little bit trickier because you'd have to rotate 5, but you'd also have to reflect it. So you could do 5 and 1, or you could do 5 and 8. And then there's something that we could notice here after we talk about 5 and 8. 5 and 8 is more of a reflection over the x-axis, to be specific. And really something we could notice now is that since 1 and 8 are congruent and 5 and 8 are congruent, by the transitive property or by substitution, 1, 5, and 8 are all congruent to each other. So 1, 5, and 8 are all congruent. Anyway, otherwise, there is one more on here. It is 7 and 4. And 7 and 4 is another rotation. Technically, you'd probably also have to translate the shape a little bit once you rotate it. But saying that one is a rotation of the other is good enough for this particular type of problem. All right. So those are two kinds of problems that you'll see, and there is one more. So if we turn the page one more time, we get ones like this, where you have to identify if the shapes are congruent given their coordinates. So you have to plot both shapes. So we'll start with that. A is 8, -6, so over 8, down 6. B is 1, -3, so over 1, down 3. C is 1, -9, so over 1, down 9. Connect the dots. And there we go. The second shape, DEF, D is over -7, up 1. E is over 0, down 2. And F is over 0, up 4. Okay, so then we're asked, are these shapes the same? Are they congruent? If your answer is yes, you think they are congruent, then we also have to describe how we would get from one to the other using translations, rotations, and reflections. If your answer is no, then you have to give some kind of a reason as to why not. Like, are two of the sides that are supposed to go together, is one of them much bigger than the other? Or is one of the angles really different looking that should match up with another angle? You have to give some kind of a reason as to why they're not congruent. And it can just be based off of your observations. On this one, though, I would say that yes, these are congruent. And now I have to show it. So one way I might show it is if I started at ABC at this triangle, I might start by doing a reflection so that I get it oriented the same way as DEF. So here's the y-axis. I'm going to reflect this over the y-axis. So step 1, reflect ABC, triangle ABC, over the y-axis. All right, so doing that, B is over 1 to the axis, so you go one more past it. C is over 1, so you go one more past it. A, you have to go over 8 to get there, so then you go 8 more past it. And there we are. Here's our new shape. And we're almost landing on top of DEF. Now that we're oriented in the same way and everything, I just have to move it up and over. Step 2, translate. Looks like I have to go over 1 to the right and up 1, 2, 3, 4, 5, 6, 7. If you want to double check and make sure that all of your points land where they're supposed to, if I go right 1 and up 7, we land on F. And if I go from here, right 1, up 7, we land on E. So we're good to go. Everything lands where it's supposed to. All right. So those are the main 3 types of problems that you're going to have. On your homework, which is the next 2 pages, you've got 10 total problems, and every single problem looks like either example 1, 2, or 3. So if you're stuck, find one that matches up with it and see if you can figure out what you're supposed to do from there. All right, that's all we've got for today. Have a good one.